When Japanese ordnance officer Captain Takeshi Yamamoto finally pried open the breech of the captured American machine gun on Bougainville in February 1944, he found himself staring at engineering tolerances he didn't believe were physically possible in a combat weapon. The ammunition belt feeding mechanism cycled 800 rounds per minute with a mechanical precision his own weapons bureau had dismissed as theoretically achievable but practically worthless. Within 48 hours of his technical examination, Yamamoto would write a classified report that would never reach Tokyo, a report that admitted what no Japanese officer was supposed to admit, that they had fundamentally miscalculated not just American industrial capacity, but the entire philosophical approach to how a modern war could be won. The weapon lay half buried in volcanic ash and mud, partially covered by a shredded tarpaulin that had once been olive drab but was now stained with rust, blood, and the distinctive yellow-brown of tropical decomposition. It was February 18th, 1944, and Captain Yamamoto had been ordered to the crashed American position not as a trophy hunter, but as an investigator. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. 3 weeks earlier, a company of the U.S. 37th Infantry Division had been overrun in a night attack on the northern perimeter of the Bougainville beachhead. The assault had been costly for both sides. The Americans had evacuated under heavy mortar fire, abandoning their heavy weapons. For the Japanese forces, it had been a rare tactical victory in a campaign that was slowly, methodically bleeding them to death. But Imperial General Headquarters in Rabaul wanted more than a tactical win. They wanted intelligence. They wanted to know what they were facing. And so Yamamoto, a 3-4-year-old weapons designer who had spent most of the war behind a desk in Kokura Arsenal, found himself trudging through a contested jungle with a squad of nervous infantrymen, searching for a specific piece of American equipment, the M2 Browning 50 caliber heavy machine gun. Yamamoto had read the field reports. He had seen the casualty figures. He knew that this weapon, more than any other single piece of equipment, had turned the tide in dozens of small but decisive engagements across the Pacific. But reading about a weapon and examining one were two entirely different experiences. As his men dug it out of the mud, Yamamoto's first impression was one of wrongness. Not in the sense of poor design, but in the sense that everything about it violated what he had been taught about machine gun doctrine. It was massive. The gun alone weighed 84 pounds, and with its tripod mount, the entire system approached 130 pounds. In the Japanese military tradition, this was absurd. Heavy weapons were supposed to be mobile, man-portable, capable of being rushed forward in a bayonet charge or repositioned quickly during a fluid engagement. The Type 92 heavy machine gun, Japan's primary equivalent, weighed only 55 pounds. It could be broken down and carried by 3 men at a running pace. This American monster looked like it was designed to be planted in place and never moved. But as Yamamoto began his examination carefully, methodically, with the trained eye of an engineer rather than a soldier, he began to see the logic. And that logic terrified him. Yamamoto had brought tools, a small portable workbench, calipers, micrometers, notepads, and a Kodak camera that had been captured from an Australian unit 6 months earlier. He set up his examination station in a captured American bunker, using sandbags to create a clean workspace. His squad commander, a lieutenant named Hiroshi Nakamura, watched with barely concealed impatience. "Captain, with respect, we need to move before the Americans counterattack," Nakamura said, his hand resting on his Type 14 pistol. "They will want this weapon back." "Then they should not have left it here," Yamamoto replied, not looking up. He was running his fingers along the barrel, feeling the machining marks. "And they will not counterattack. Not for this. They have 50 more." This was not arrogance. It was mathematics. Yamamoto had seen the intelligence estimates. The Americans were producing these weapons at a rate that seemed physically impossible, dozens per day from multiple factories. The Japanese, by contrast, had built perhaps 40,000 Type 92 seconds in total since the weapon's introduction in 1932. The Americans had built more M2 Brownings in the last 6 months than Japan had built heavy machine guns in a decade. But numbers were only part of the story. What Yamamoto wanted to understand was why this weapon worked so devastatingly well. He began with the bolt mechanism. In the Japanese Type 92, the bolt was a relatively simple affair, a heavy steel block that slammed back and forth, powered by the recoil of the gun itself. It was reliable enough, but it had limitations. The rate of fire was fixed at around 450 rounds per minute, and the mechanism was prone to overheating. The Browning's bolt was something else entirely. As Yamamoto carefully disassembled it, he found himself looking at a short recoil system of extraordinary sophistication. The barrel and bolt recoiled together for a brief moment before unlocking, allowing the bolt to continue rearward while the barrel stopped. This kept the barrel cooler and allowed for a much higher rate of fire, but it was the tolerances that shocked him. Using his micrometer, Yamamoto measured the clearance between the bolt and the receiver. It was less than 2/1000ths of an inch. The locking lugs that secured the bolt to the barrel were machined to a precision he had only seen in laboratory instruments, not combat weapons. The entire mechanism was designed not just to function, but to function perfectly, under the most extreme conditions imaginable. He photographed everything. He sketched diagrams. He took measurements and recorded them in his notebook with the meticulous care of a man who understood that this information might be the most valuable intelligence he would ever gather. Then he moved to the barrel. The barrel was 45 inches long, and it was a single piece of chrome-molybdenum steel that had been hammer-forged and then precision-reamed. Yamamoto ran a bore scope down its length and found rifling that looked almost mirror-smooth. The Japanese Type 92 used a barrel that was adequate, functional, but nothing like this. This was the barrel of a weapon designed to fire thousands of rounds without significant degradation. "What are you learning?" Nakamura asked, crouching beside him. "That we have been approaching this problem incorrectly," Yamamoto said quietly. He was staring at the barrel, turning it over in his hands. "We have been building machine guns as if they were rifles. The Americans are building machine guns as if they were systems." "I don't understand." "Neither did I," Yamamoto admitted. "But I am beginning to. If the gun itself was a revelation, the ammunition was a sermon." Yamamoto had found 6 metal ammunition cans in the bunker, each containing a belt of 105 rounds. He opened one and carefully examined the cartridges. The .50 caliber BMG round Browning machine gun was enormous compared to the 7.7 mm rounds used in Japanese machine guns. Each cartridge was over 5 inches long and weighed nearly 4 ounces. But it wasn't the size that fascinated him, it was the consistency. He selected 10 rounds at random and weighed them on a precision scale he had brought. The variance in weight was less than half a grain, an almost absurd level of quality control for mass-produced ammunition. He measured the overall length of each cartridge. Again, the variance was microscopic. In Japanese ammunition production, quality control was adequate. Rounds worked. They fired. But there were variations, small differences in powder charge, in bullet weight, in case dimensions. These variations were considered acceptable, even inevitable in mass production. After all, a machine gun was meant to throw a large volume of fire downrange. Precision was for rifles. But the Americans had apparently decided that mass production did not mean sacrificing precision. Every round was identical. Every round would feed smoothly. Every round would fire with the same velocity, the same trajectory, the same impact. This was not just manufacturing. This was a philosophy of war. Yamamoto loaded a belt into the Browning's feed mechanism and manually cycled the action. The rounds fed with a smoothness that seemed almost liquid. There were no catches, no snags. The cartridges entered the chamber perfectly centered, every time. He understood now why the weapon could fire 800 rounds per minute. It wasn't just the mechanical design. It was the entire system, gun, ammunition, and the industrial process that produced both working in perfect synchronization. "This is not a machine gun," Yamamoto said, almost to himself. "This is an integrated weapons system." Nakamura frowned. "What is the difference?" "Everything," Yamamoto said. "Everything is the difference." Yamamoto knew that measurements and diagrams were not enough. He needed to fire the weapon. He needed to see it perform. This was dangerous. The sound of an American .50 caliber would carry for miles, and it would draw attention from both sides. The Americans would investigate. His own command might think they were under attack and shell his position. But Yamamoto was past caring about personal safety. He needed to know. They moved to a small clearing 100 yards from the bunker. Yamamoto set up the Browning on its tripod, facing toward a hillside that would serve as a backstop. He loaded a fresh belt of ammunition. His hands were steady. "Everyone take cover," he ordered. "This will be loud." He took position behind the gun, his thumbs on the butterfly trigger. He had never fired an American weapon before. He had fired thousands of rounds through Japanese machine guns. But this was different. He squeezed the trigger. The sound was apocalyptic. Not the rapid chatter of a light machine gun, but a deep, thunderous hammering that seemed to shake the air itself. The muzzle blast was a continuous tongue of flame 3 feet long. Brass casings arced through the air in a glittering stream, landing in a pile at his feet. Yamamoto held the trigger down for a 5-second burst, approximately 65 rounds. When he released the trigger, the silence was stunning. His ears were ringing. His shoulders ached from the recoil, transmitted through the spade grips. But his eyes were locked on the hillside. The impacts were clustered in an area roughly the size of a tatami mat. At a range of approximately 200 yards, he had just placed 65 half-inch diameter projectiles into a target zone that a single man could cover with his body. No Japanese machine gun could do this. The Type 92 was accurate enough for suppressive fire, but this was precision destruction. He fired another burst, then another. The barrel was heating up, but not dangerously. The weapon was designed to handle sustained fire. After approximately 200 rounds, Yamamoto stopped and examined the barrel. It was hot enough to make the air shimmer, but the bore was still clean. No fouling, no degradation. A Japanese Type 92 would have needed a barrel change by now. Yamamoto felt something unfamiliar in his chest. It took him a moment to recognize it. It was despair. Not the emotional despair of a soldier facing death, but the cold, analytical despair of an engineer who has just seen a problem that has no solution. The report that was never sent that night. By candlelight in a dugout command post, Captain Yamamoto wrote his report. He wrote it in careful, formal Japanese, using the proper military terminology and organizational structure. He included his measurements, his diagrams, his photographs. He documented everything, but as he wrote, he found himself including observations that went beyond technical specifications. He found himself trying to explain not just what the weapon was, but what it represented. The American M2 heavy machine gun is not merely a superior weapon, he wrote. It is the product of a fundamentally different industrial and military philosophy. Where we have prioritized warrior spirit and tactical flexibility, the Americans have prioritized systematic integration and sustainable firepower. The weapon's true strength is not in its mechanical design, though that design is formidable. Its true strength is in the ecosystem that supports it. The ammunition is manufactured to tolerances that we reserve for laboratory instruments. The logistical system delivers these weapons and millions of rounds of ammunition to every corner of the Pacific theater. The training ensures that every gunner can operate the weapon to its full potential. We have been fighting this war as if it were 1905, believing that superior spirit and tactical audacity could overcome material deficiencies. The Americans have been fighting this war as if it were 1944, treating warfare as an industrial engineering problem to be solved through superior processes and resources. He paused, his brush hovering over the paper. What he wanted to write next was dangerous. It was defeatist. It was the kind of observation that could get him recalled to Tokyo for re-education or simply shot for undermining morale. But he wrote it anyway. Based on this examination, it is my assessment that we cannot match this weapon system with our current industrial capacity. We cannot outproduce the Americans. We cannot match their quality control. We cannot replicate their logistical support. Any attempt to defeat this weapon through tactical means alone will result in unacceptable casualties. The question is no longer whether we can build a better machine gun. The question is whether we can build a better system, and I do not believe we can. Yamamoto signed the report, dated it, and placed it in an envelope marked for immediate dispatch to Rabaul, to be forwarded to Imperial General Headquarters in Tokyo. The report never arrived. 4 days later, American forces launched a major offensive to recapture the northern perimeter. Yamamoto's position was hit by a naval artillery barrage that lasted 6 hours. When American infantry finally moved through the area, they found the bunker collapsed, the Japanese dead buried under tons of earth and shattered coral. Among the wreckage, a patrol found a burned notebook and some water-damaged photographs of machine gun components. They were collected, catalogued, and eventually filed away in a military intelligence archive, where they remain to this day, their significance unrecognized. The captured M2 Browning was recovered by American forces. It was cleaned, inspected, and returned to service. It would fire another 10,000 rounds before the war's end, and Captain Takeshi Yamamoto, the man who understood what that weapon truly represented, became another statistic in a war that was increasingly being decided not by individual warriors, but by the cold mathematics of industrial production. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. While Captain Yamamoto had been conducting his examination of a single weapon in the jungles of Bougainville, 7,000 miles away in Hartford, Connecticut, a different kind of battle was being waged. This battle had no bullets, no blood, no heroic charges. It was fought with blueprints, production schedules, and quality control inspections. And it was a battle that Japan had already lost before the first shot of the Pacific War had been fired. The Colt, patent firearms manufacturing company, occupied a sprawling complex along the Connecticut River. In February 1944, the same month Yamamoto was examining his captured weapon, the Hartford plant was operating on a 3-shift, 24-hour schedule. The building never slept. The sound of machining never stopped. Inside Building 7, a man named Robert Hendricks was having a very different kind of revelation. Hendricks was 52 years old, a machinist who had worked for Colt since 1916. He had started as an apprentice, learning to operate lathes and milling machines in an era when precision was measured in thousandths of an inch and considered remarkable. Now, in 1944, he was a shift supervisor overseeing the production of M2 Browning receiver assemblies. The receiver, the main body of the weapon, was one of the most critical components. It had to be machined to tolerances that Hendricks would have considered impossible when he started his career. The bolt had to slide within it with almost no lateral play, yet it could never bind or catch. The tolerances were measured in 10,000ths of an inch. Hendricks stood at Station 14, watching a young woman named Patricia Chen operate a vertical milling machine. Chen was 23 years old. She had been working in a department store before the war. She had never touched a machine tool in her life until 8 months ago. Now she was cutting the bolt channel in an M2 receiver with a precision that would have taken Hendricks 5 years of apprenticeship to achieve. The machine itself was part of the miracle. It was a Cincinnati milling machine, modified specifically for this operation. It had cam-actuated automatic feed, hardened cutting tools, and most importantly, a series of gauges and stops that made it almost impossible to produce an out-of-specification part. Chen's job was not to manually guide the cutting head through a complex series of movements. Her job was to load the raw casting into the fixture, activate the automatic cycle, and then inspect the finished part with a series of go, no-go gauges. The machine did the skilled work. She provided the quality control. "How many have you done today?" Hendricks asked. Chen glanced at her tally sheet. 47 so far. Target is 65 by end of shift. 47 receivers, each one capable of housing a bolt mechanism that would fire 800 rounds per minute. Each one machined to tolerances that would have been considered laboratory-grade precision a decade earlier. And this was just one station, in one building, in one factory. Across the United States, there were dozens of facilities producing M2 components. The barrels came from a specialized forge in Pennsylvania. The bolts were machined in Ohio. The feed mechanisms were assembled in Massachusetts. Each component flowed into the system, was inspected, was integrated, and emerged as a complete weapon. The scale was incomprehensible to an individual observer. Hendricks had seen the monthly production figures. In February 1944, American factories would produce approximately 3,500 M2 Browning machine guns. That was more than the entire annual production of Japanese heavy machine guns. And it wasn't just the guns, it was the ammunition. In Lake City, Missouri, the Lake City Army ammunition plant occupied 4 square miles of carefully organized industrial space. The plant had been built in 1941, designed from the ground up for a single purpose: mass production of 50 caliber ammunition. The production line was a marvel of coordinated automation. Raw brass entered at one end, finished cartridges emerged at the other. In between were hundreds of steps, each one precisely calibrated, each one inspected. The brass cases were drawn from sheet metal in massive hydraulic presses, then trimmed to exact length. The primer pockets were formed with machine die precision. The primers themselves, tiny but critical components that had to fire with absolute reliability, were manufactured in a separate facility under conditions that approached pharmaceutical-grade cleanliness. The powder was measured by automated equipment that could dispense charges with a variance of less than 0.1 grain. The bullets were swaged from lead cores and copper jackets, then inspected optically for defects. Everything was measured, everything was tested. A single production line at Lake City could produce 100,000 rounds per day. The plant had 12 production lines. By the time Captain Yamamoto was examining his captured weapon in the Pacific, Lake City had already produced over 2 billion rounds of 50 caliber ammunition, and production was accelerating. This was the invisible half of the weapon system. Yamamoto had understood the gun. He had measured its precision and marveled at its design. But he had not seen the industrial cathedral that made it possible. The American approach to machine gun employment was fundamentally different from the Japanese doctrine, and that difference was rooted in a philosophy that predated the war by decades. In the Japanese military tradition, machine guns were supporting weapons. They provided covering fire for infantry assaults. They defended key positions. But the decisive element in combat was always the infantryman with his rifle and bayonet. The warrior spirit, the willingness to close with the enemy and destroy him in direct combat, was the ultimate measure of military effectiveness. The Americans had a different idea. In the U.S. Army and Marine Corps, machine guns were not supporting weapons. They were the primary killing instruments. Infantry existed to maneuver the machine guns into position, to protect them, to exploit the destruction they created. The rifle was secondary. The machine gun was the weapon that won battles. This doctrine had been developed during World War I, refined during the interwar period, and perfected in the crucible of the Pacific War. And the M2 Browning was its ultimate expression. Sergeant First Class Thomas Kovacs had learned this doctrine the hard way. He was 28 years old, a career soldier who had enlisted in 1936 when jobs were scarce and the army offered steady pay. He had landed on Guadalcanal in August 1942 as a private first class, carrying an M1 Garand and all the naive courage of a man who had never been shot at. By February 1944, he was a sergeant and a true believer in the gospel of the 50 caliber. Kovacs was now stationed on New Georgia, part of the 43rd Infantry Division. His squad was responsible for a section of the perimeter defense, and his most valuable asset was not his 12 riflemen. It was the M2 Browning mounted in a reinforced bunker overlooking a natural approach route through the jungle. The bunker was a masterpiece of field engineering. It had been built over the course of 3 weeks by combat engineers who understood exactly what they were creating. The walls were sandbags backed by coral aggregate and logs proof against everything except a direct hit from heavy artillery. The firing port was narrow, protecting the gun crew while offering a 120-degree field of fire. But the real genius was in the positioning. The gun was sighted to cover a natural corridor in the jungle, a relatively open space where the undergrowth thinned and the ground rose slightly. Any attack coming from the Japanese positions would have to come through that corridor. There was no other practical route, and that corridor was a killing ground. Kovacs had personally ranged the field of fire. He knew the exact distance to key terrain features: a distinctive palm tree at 300 yards, a fallen log at 450 yards, the edge of a small stream at 600 yards. He had test-fired the weapon at each range point, adjusting the elevation and noting the fall of shot. The result was a precisely mapped death zone. Kovacs could put fire on any point in that corridor within seconds, and he could do it at night, in rain, in any conditions, because he had memorized the site settings. This was not the fluid, aggressive tactics of Japanese close assault doctrine. This was something else entirely, a kind of industrial ambush, where the weapon and its position were more important than the individual soldier operating it. On the night of February 27th, 1944, Kovacs learned just how effective this system could be. The attack came at 0230 hours, in the darkest part of the night, when exhaustion dulls the senses and fear lives in the imagination. There had been no warning, no artillery preparation, no probing attacks, just silence, and then suddenly, movement. Kovacs was awake, as he always was during his watch rotation. He had learned on Guadalcanal that sleep could kill you. His gunner, a 20-year-old private from Michigan named Eddie Kowalski, was behind the M2, his hands on the spade grips, his eyes straining into the darkness. "You hear that?" Kowalski whispered. Kovacs heard it, a rustling in the jungle. Not the normal sounds of wind and animals, but something purposeful, something human. "Steady," Kovacs said. His voice was calm, almost conversational. "Wait for them to enter the zone." A flare went up from another sector of the perimeter, probably triggered by a nervous sentry. The magnesium light cast the jungle in stark black and white, creating shadows that seemed to move independently of the vegetation. And in that moment of illumination, Kovacs saw them. A company-strength assault, perhaps 150 men, moving in a loose formation through the corridor. They were advancing rapidly, bent low, rifles at the ready. They had made the same calculation every attacking force made, that speed and surprise could overwhelm a defensive position before the defenders could react. They had calculated incorrectly. "Target, troops in the open, 400 yards, Kovacs said, his voice still utterly calm. "Fire, when ready." Kowalski didn't hesitate. His thumbs pressed the butterfly trigger, and the M2 roared to life. The first burst was a 5-second torrent of fire, approximately 65 rounds. Kowalski was firing in controlled bursts, just as he had been trained. 5 seconds on, 2 seconds off to let the barrel cool slightly, then another burst. The effect was catastrophic. At 400 yards, the 50 caliber rounds were still traveling at over 2,000 feet per second. They didn't just kill, they destroyed. A man hit in the torso was often torn in half by the sheer kinetic energy. A near miss could kill through hydrostatic shock or flying fragments of metal and bone. The first burst cut down the lead elements of the assault. The following bursts swept methodically across the corridor, left to right, then right to left. Kowalski was not aiming at individuals. He was covering the zone. The tracer rounds every fifth round in the belt created a visible stream of fire that seemed to sweep through the darkness like a scythe. The non-tracer rounds, invisible in the dark, were the ones that did the real killing. Kovacs watched through his binoculars, spotting targets and calling corrections. Left 10 yards. Good. Hold there. Sweep right. The Japanese assault faltered, then broke. Men who moments before had been advancing with purpose were now scrambling for cover, dragging their wounded, trying desperately to escape the beaten zone. But Kovacs had planned for that too. He had pre-positioned stakes, marking the likely retreat routes. Target, withdrawing troops, reference point Baker, adjust fire. Another group of men torn apart by the invisible storm of half-inch projectiles. The entire engagement lasted less than 3 minutes. When it was over, the jungle was silent again, except for the moaning of the wounded. Kowalski was breathing hard, his hands trembling slightly from adrenaline. "Jesus Christ," he muttered. Kovacs laid a hand on his shoulder. "You did good, Eddie. You did exactly what you were trained to do." "How many did we?" "Doesn't matter," Kovacs said, though he had a pretty good estimate. "Probably 30 to 40 dead, at least as many wounded. A company-strength assault reduced to a shattered remnant in the time it takes to smoke a cigarette. And they had fired perhaps 400 rounds, less than 4 ammunition cans. Reload," Kovacs ordered. "They might try again." The Japanese assault doctrine relied on momentum, on the shock of sudden attack overwhelming the defense. That momentum was broken. The survivors would withdraw, regroup, and try to find another way. There was no other way. In the morning light, American patrols moved through the corridor to assess the damage and collect intelligence. What they found confirmed what Kovacs already knew. The Japanese dead were concentrated in precise zones corresponding exactly to the M2's field of fire. The density of casualties was highest in the center of the corridor, where Kowalski had concentrated his initial fire and extended outward in a pattern that could be predicted mathematically. This was not combat as the samurai had understood it. This was not the test of individual courage and skill. This was geometry. This was ballistics. This was the cold logic of fire superiority. A Japanese officer, a captain, judging by his insignia, had been killed approximately 380 yards from Kovacs's position. In his map case, they found operational orders for the attack. The orders spoke of overwhelming the enemy through spiritual superiority and achieving victory through the purity of our warriors' devotion. There was no mention of suppressive fire, no discussion of fire and maneuver, no consideration of how to defeat an entrenched machine gun position. The Japanese doctrine assumed that courage and determination could overcome material disadvantages. It assumed that the willingness to die for the emperor was itself a weapon that no amount of industrial production could defeat. That assumption was wrong. A Marine, Corps Lieutenant named James Bradford, a 1942 graduate of the Naval Academy, was part of the patrol. He had been educated in military history and strategy. He understood what he was seeing. "This isn't even a fair fight anymore," he said to Kovacs, looking at the carnage. "They're bringing samurai swords to a machine gun factory." Kovacs nodded slowly. He had been thinking the same thing, but hadn't had the words for it. "The thing is," Bradford continued, "they know it. They have to know it. Every attack like this teaches them the same lesson. But they can't change. Their entire military culture is built on the idea that spirit matters more than steel. To admit that's wrong would be to admit that everything they've built their empire on is a lie." "So they just keep coming?" Kovacs asked. "They keep coming," Bradford confirmed. and we keep killing them. Not because we're better warriors, because we have a better system. What neither Yamamoto nor the Japanese commanders fully grasped was that the M2 Browning was only the visible tip of an enormous logistical iceberg. Every weapon on the front lines was supported by a supply chain that stretched back across the Pacific, across the continental United States, into mines and factories and foundries that most soldiers would never see. Consider a single engagement like the one Kovacs had just fought. 400 rounds of .50 caliber ammunition expended. In the Japanese military system, that would represent a significant expenditure of resources, one that would need to be carefully justified and rationed. In the American system, it was a rounding error. Within 24 hours of that engagement, a supply convoy would arrive at Kovacs's position. It would include, among many other items, 10 fresh cans of .50 caliber ammunition, 1,050 rounds. The ammunition would have been manufactured in Missouri, shipped by rail to San Francisco, loaded onto a Liberty ship, transported 6,000 miles across the Pacific, offloaded at a forward supply base, and then trucked forward to the front lines. And this was happening simultaneously for thousands of units across the entire Pacific theater. The Japanese could not match this. Their merchant fleet was being systematically destroyed by American submarines. Their factories were working at maximum capacity and still could not keep pace with demand. Their forward supply bases were subject to constant air attack. By early 1944, many Japanese frontline units were rationing ammunition. Machine gunners were ordered to fire only when they had a clear target. Artillery was used sparingly, saved for critical moments. The Americans had the opposite problem. They had so much ammunition that logistics officers worried about storage space, not shortages. This disparity created a psychological effect that was almost as important as the material advantage. American soldiers knew that if they got into trouble, they could call for support, and it would arrive. Artillery would fire, air support would come, supplies would be delivered. Japanese soldiers knew that they were on their own. No reinforcements were coming, no resupply was possible. Every battle was a slow process of attrition that they would ultimately lose. The M2 Browning, with its insatiable appetite for ammunition and its devastating effectiveness, was both the symbol and the instrument of this disparity. It represented not just American industrial capacity, but American willingness to use that capacity without restraint. In the weeks following the night assault, Kovacs's position was attacked 3 more times. Each time, the M2 broke up the assault with minimal American casualties. Each time, the Japanese left their dead in the corridor and withdrew. Kowalski, the young gunner, kept an informal count. By his calculation, their single weapon had killed or wounded over 200 enemy soldiers in a 6-week period. The gun itself had fired approximately 15,000 rounds. It had required 2 barrel changes and routine maintenance, but it had never malfunctioned, never failed when called upon. "You know what's crazy?" Kowalski said one afternoon, cleaning the weapon after another engagement. "This gun was probably built by some lady in a factory who'd never fired a gun in her life, and it works better than anything their master gunsmiths can build." Kovacs thought about that. He thought about Patricia Chen, though he didn't know her name, standing at her milling machine in Connecticut. He thought about the workers at Lake City, producing millions of rounds with robotic precision. He thought about the engineers who had designed the feeding mechanism, the metallurgists who had developed the barrel steel, the logisticians who had created the supply chain. "It's not about the individual," Kovacs said finally. "It's about the system. They've got warrior spirit, we've got systematic production, and systematic production wins." This was the truth that Captain Yamamoto had glimpsed in his examination of the captured weapon. This was the reality that the Japanese military leadership could not accept, even as it ground their armies into dust. The war would continue for another 18 months. Hundreds of thousands more would die. But the outcome was no longer in doubt, if it ever had been. The katana had met the machine gun factory. The code of Bushido had collided with the principles of industrial mass production, and no amount of courage, no depth of devotion, no purity of spirit could change the mathematics of that equation. In the end, the Pacific War was not decided by warriors. It was decided by machinists, engineers, factory workers, and logistics officers, ordinary people performing their small, practiced roles in a vast system that transformed American industrial capacity into overwhelming combat power. The M2 Browning, the .50 caliber machine gun, would remain in service for the next 80 years, essentially unchanged. It would fire in Korea, Vietnam, Iraq, Afghanistan. It would outlast the empire it helped defeat by 3/4 of a century, and somewhere in a military archive, water-damaged photographs of machine gun components remain filed away, the last testament of Captain Takeshi Yamamoto, an engineer who understood too late that the war had been lost before it began, not on the battlefield, but in the factories, foundries, and engineering halls of a nation that had turned warfare itself into an industrial process. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.